Ever notice how a shiny, crisp apple, seemingly perfect, begins to turn brown after a while? It's a common sight. Or how a loaf of bread, once soft and inviting, starts to grow fuzzy, colorful spots. Food is constantly in a race against time, a battle against decay, and time usually wins, doesn't it? Yet some foods, like golden honey, seem to defy the odds and last for ages, almost indefinitely. While delicate strawberries, bursting with flavor, spoil incredibly fast. Why this dramatic difference? It's all about the environment surrounding the food. Think of food as a house, a habitat for tiny organisms. Some, like juicy strawberries, are luxury resorts for microbes, moist, sugary, and openly exposed to the air, making them incredibly appealing. Honey, on the other hand, is more like a desert, far too dry and inhospitable for most invaders to thrive. When you cut into a crisp apple, enzymes that were safely tucked away inside react with the oxygen in the air, causing that familiar browning. It might not be completely spoiled just yet, but the process of breakdown has definitely begun. This breakdown makes the food even more inviting, a welcome sign for microscopic invaders looking for a new home. For thousands of years, humans have been in a constant battle against spoilage, using the power of the sun, the preserving properties of salt, the aromatic effects of smoke, and the chilling embrace of ice to keep our food safe and edible. Every modern refrigerator and every can of soup on the shelf is a direct result of centuries of accumulated food science and innovation. So what's the real secret to keeping food fresh and delicious for longer? It's all about understanding the enemy we're up against. Let's take a closer look and meet them face to face. Meet the real culprits behind food spoilage, the unseen army that wages war on our leftovers. It's bacteria, yeasts, and molds, a microscopic trio of troublemakers. These are tiny organisms, lurking everywhere, patiently waiting for the right conditions to multiply and thrive. And what is their ideal party zone? It's food, water, and warmth, the perfect breeding ground. Now, not all bacteria are villains. Some can be helpful, like the ones in yogurt, but others are harmful, such as Salmonella and E. coli, which can cause serious illness. The bad ones actively break down food, consuming its nutrients and altering its structure. This process causes unpleasant odors, a slimy texture, and ultimately, sickness if consumed. Just imagine, a single bacterium can multiply into millions within just a few hours, especially if the environment is warm and moist. Molds, on the other hand, are a bit tougher. They can grow in drier and more acidic places than bacteria prefer. That fuzzy stuff you see on bread? That's just the visible tip of the iceberg. The mold's roots or mycelium run deep within the food. But it's not just these microorganisms we have to worry about. Oxygen and moisture also play a significant role in food spoilage. Oxygen, for example, turns fats rancid, giving them an unpleasant taste and smell. It also fuels browning reactions in fruits and vegetables. And as we've already discussed, moisture creates the perfect environment for microbes to thrive and multiply. That's why dry foods like pasta and crackers tend to last longer. They're essentially deserts for microbes, offering no water for them to survive. So when you take away water, you effectively take away their power to spoil our food. That's precisely why controlling the environment in which we store our food is absolutely key to preventing spoilage. In essence, spoilage is a constant battle of conditions, a tug of war between preservation and decay. Next, let's delve into the strategies and techniques we can employ to fight back against these unseen food wreckers. The science of staying fresh is all about tipping the balance in our favor, creating conditions that inhibit microbial growth and slow down spoilage. Here's how we can do it. Food preservation is fundamentally about making life as difficult as possible for microbes. These tiny organisms are the primary cause of food spoilage. We achieve this by carefully controlling key environmental factors like temperature, moisture levels, the presence of oxygen, and even the acidity or pH. Refrigeration works by significantly slowing down the metabolic processes of microbes. This buys us valuable time, extending the shelf life of our food by days or even weeks. Freezing takes this a step further, nearly stopping microbial activity altogether. This allows us to preserve food for extended periods, often for months at a time. Applying heat, as seen in pasteurization or canning, is a more direct approach, killing microbes outright and sterilizing the food. Drying is another effective method, removing the water that microbes need to survive and thrive. Think of classic examples like beef jerky or naturally sweet dried fruit. Salt and sugar work by drawing water out of microbial cells through a process called osmosis, effectively dehydrating them from the inside out, creating an inhospitable environment. Introducing acid like the vinegar used in pickling creates a highly acidic environment that most spoilage microbes simply cannot tolerate. Fermentation takes a different approach, using beneficial bacteria to produce acids. This process builds natural defenses against harmful microorganisms. Each and every method is essentially a clever trap, designed to slow down, stop, or completely destroy the forces of spoilage. These time-tested techniques allow us to keep our food safe for consumption, ensuring it remains nutritious and, of course, tasty. Food preservation is truly a fascinating blend of both art and science. So, let's take a look at how these ingenious methods have evolved over time. From the ancient tricks passed down through generations, all the way to the modern marvels of food technology, the fundamental goal remains the same: to keep our food fresh and safe to eat for longer periods of time. Food preservation has a long history. Salting, sugaring, drying, and heating are ancient but effective. Salted meats and jams kept people fed through winters and voyages. Canning, invented in the 1800s, uses heat and a vacuum seal to lock out microbes, hence, shelf-stable beans. Pasteurization gently heats milk to kill harmful bacteria, making it safe and long-lasting. Drying, from sun-dried tomatoes to jerky, removes moisture and locks in flavor. Fermentation lets good microbes protect food and create new flavors: sauerkraut, yogurt, and more. Modern methods like vacuum sealing and modified atmosphere packaging remove oxygen or change the air, slowing decay. Old and new techniques work together to keep our food safe and delicious. Thanks to these innovations, our kitchens are stocked year-round. Preservation is a story of human ingenuity, but it's about more than just taste. Food preservation is about survival, stability, and reducing waste. It bridges the gap between harvest and hunger, letting us eat year-round and enjoy foods from around the world. Techniques like canning and freezing connect farmers and consumers everywhere. Without preservation, diets would be limited to local, seasonal foods. It also fights food waste. About a third of all food is lost yearly, much due to spoilage. Making food last longer means less waste and more respect for resources. Every preserved food is a triumph of science and tradition. From ancient salting to modern packaging, the goal is the same: safe, delicious food for all. That's the real magic behind every well-preserved bite.